One of the most important bit of any software system existing anywhere on cloud or hosted locally is the whole bit about security, and security basically consists of predominantly authorization and authentication. Those are the two very important bits, actually in the reverse order: authentication and authorization. Now let's look at, there are many standards on how this activity is performed. Most popular mechanism is OAuth 2. We will look at OAuth 2 in a later video. For now, let's consider, if we were just building a web system for ourselves, we didn't want to integrate with other third party providers, how would we introduce security into our system? So let's look at that bit, and then in a later video we will get to something like OAuth 2. So the first thing that we need to do is again get to our pom.xml and add the security related stuff. So the main thing to start with is the Spring Boot Starter Rig Security. So we added that. We would also add a few other things that will be required as part of this video, but they may not be really required with the basic security concepts. One of them is Spring expressions. Spring expression, not expressions. This one. Let me just increase the font size a little bit. So we were here, we added a Spring expression. Then we also need to add a Spring Security Web. We also need to add a Spring Security config, and apart from that we also want to add JSON because we might be using it. I am not sure, but let's just add it because eventually it will be required somewhere. So we added these bunch of things. Let's just refresh Maven changes and then let's get started on it. Now one of the first things related to security is what we call, one of the main things that we do when we talk about security is what we call role-based access control. So one of the first things that we want to define is the concept of roles. So let's create a we need to create a new class. So let's create a package called security, and within that we create a class that is called role. The role class is nothing but our abstraction of the concept of the role, and we will see how we use it eventually. So how does this role look like? For now we will have few roles. So first thing is, rather than class we will make it a enum because it is just an enumeration, and let's define bunch of roles. The first of the roles is user, which is the role that we give to a ordinary user. We assign it a value 1, and then we have another role which is tester, and we are basically using a mask kind of behavior, so that's why we are left shifting it by 1. So next is tester, third is admin, and then we have refresh. The refresh role is specifically required to refresh the tokens for authentication, and it will only be used for one purpose. And another role is anonymous. So these are the bunch of rows that we have defined. and we will store it in a variable called mask. Now we need to define a constructor for this enum, and we need to define another helper method that, given a mask, will return us a list of roles. This will be useful for our code, and we will define it as a static because we want essentially to be able to call it without creating a class. So basically this function, this method returns a set of roles, and we pass a mask as an argument to it. Now basically the point here is simple. We will look at each of the bits, and whichever roles are set, we will add them into the set. So let us define a set which is return value, let it be a hash set, and then we say for role r into values. So all the values that are defined within the enum, we will check if that particular mask is set or not. So r dot mask and incoming mask is not equal to 0. That would essentially mean that the bit that is corresponding to that particular role is set. So if that is the case, then we add that role into the return value. So for example, in this case, if we were to pass 0x 01 and the 02, so it will basically add two values, and once we run through this for loop, then we return the return value. So this is one of our helper method that we would be using eventually. Now the next thing that we need to do is basically somewhere we will need to store the roles that a user is allowed, and for now we can again there is a better way of doing it, but right now what we are trying to do is how to do it in Spring. So let us try to add it in the user entity itself. So we have the user entity already, and within that we add a private long mask, and let us also add private string auth token that we might be returning, and let us add an expiry value. So we add bunch of these things here, and we also want to make sure, actually I think this is enough. So let us start with it. We just add getter and setter for the new variable that we have defined. So let us go to generate getter and setter, and we add all these things, and so we have our user entity class that is ready for it. So basically if you look at it, these are the three member variables that we have added, and we have added getters and setters for those. So let us move on to the next bit that we need to do, which is define a concept of granted authority, and this is a very Spring specific concept, and basically there is a interface called granted authority that exists, and if we want to use the Spring security, we need to have an implementation of that. So we define it within our security class, security package. We create a new class called user authority, and that class that class has to implement granted authority, and now we need to implement certain methods. There is a get authority method that we need to implement. So, we have to basically store this authority somewhere, and for now let us define a string variable private final string authority, and we return this variable from here. Now, we need to define a constructor where this is initialized, and we also need certain helper method that we need to define, so that we can create these authorities from the roles that we had earlier defined, because Spring does not understand our roles, but we want to use our roles as a enumeration. We do not want them to be just plain strings, because strings are very error prone. So, that is why we will use our role class to essentially create these user authorities, and basically that is why we are defining these two helper methods, one which will convert authority to role, and other which will convert role to authority. So, this guy takes a list of roles, and basically what we are going to do is we can use the Java 8 streams. Okay, we have to make it a list. So, basically if you see this particular piece of code will take all the list of roles and return us a set of user authorities. Now, we need to write a very similar one where basically we want to do the same thing from mask. So, basically it is very similar to previous one. Only thing that we do is we first use the helper method that we had defined in the method that we had, which is create from mask, and this will return us, if you look at the create from mask, it will return us a set of roles, and then we call the exact same thing as we called earlier. So, if you see this particular, and we can just call return on it. So, if you see this particular piece of code, it is essentially going to take a mask, convert that mask to a list of roles, a set of roles, and convert that set of roles to a set of authorities. So, this is our user authority class that we are going to use very soon. And now let us look at the next bit that we need to do, which is essentially to define a principal. Now, within Spring context, essentially a identification or a user is represented by a principal, because we are doing our own concept of user. So, we are going to define a new principal for ourselves, and so let us call a user password principal, and we define an implementation for it, and and basically every principal in Spring has to implement a principal interface, which is the Java security principal interface. And if you look at, there are these two methods that needs to be implemented. Right now we are not so much worried about the implies method, but we would implement a get name method. And again we will store, because we are predominantly doing username and password, this class will contain username and password, and the username is essentially going to be what gets mapped to the name. Because these are the values we will be getting from the internet, it is better to make them optional, because they would be getting from internet, so we will make them optional. And because they are optional, we could just make them final as well, because they are not going to change here. So let's make both of them final and optional, and here then we have to say username.get. Now we need to define a constructor for it, and the constructor would be taking two values. One is optional for username and another optional for password. So we have that there. That takes care of defining a principal for ourselves. Now after we have done with principal, I think most okay, one more thing is left. With each principal we also need to have a provider. So let's define a provider for ourselves. Let's call it username password provider, and this particular provider has to implement a authentication provider, and it basically needs to have two methods defined, which we will define. The first method is authenticate. Now if you really see, this is the method that gets called when we are when actual authentication process is done. So if you really see what we need to do, every authentication object that is incoming here will contain the principal. Now in our case what we have said is that we were going to send username authentication provider for this particular purpose. So let's define it here. So username password principal is equal to authentication.get principal. Now this particular object is actually a object is returned, so we have to downcast it to our particular class. We have to make sure this is of the same type, but because we are going to write both ends of this process, we know that whenever our code reaches here, authentication will contain a principal of this type. So we can cast it down to this particular class, and this, so we got a principal object. Now we know the principal contains both username and password. So what we basically need to do is pull out both the username and password, make sure they contain the valid value, check it against the database, and if they contain the right values, then we say that authentication is successful. Otherwise we declare that the credentials could not be matched. So let's do it. If principal dot get username. Okay, we have to define these methods on principal object, so let's go and do that. Let's add getters and setters. We don't need setters because both are final, only getters will be allowed. And so get username is present. If it is present, then we check, then we look at our repository and search for it. So we basically have to have a user repository in this context. So as I mentioned in one of the earlier videos, because these are beans, we can just auto wire them. And user repository dot find by entity, email or username. Now this, if you see, this particular method is not good for us because it takes both email and username. So we have to define another method that just finds user by username, and we pass a username to it, which is string username equal to principal dot get username dot get. Now let's go and define this thing in the user repository. So we go here and we can just copy this query, select UE from user entity where we can get rid of the email clause and just search for username. I think this should be good enough for us. So we got a OUE. Now we check if it really had a valid value. If it is present, then we have a user entity object. So user entity UE equal to OUE.get. So this is our user entity. Now the next thing that we need to do is basically match the password. Did the password work? So we say if. So normally we are going to have a password manager class. So right now I am just going to use it and then we will define it later. It is going to be a, let's define that first. Okay, so let's define the password manager class first and then we will come back to this. So let's now keep it within security package itself. So we go to password manager. Okay, so before we complete our implementation of a password manager, we also need to define a password encoder. If you remember, right now we are just storing password as a plain text, which is definitely not a great idea. So before the password field is stored into our system and everything, I mean matching or anything else is done, we essentially need to encrypt it. Now the best way to encrypt it is actually to define a password encoder, and Spring has a password encoder which is called delegating password encoder, which will encode it in a way that multiple algorithms can be used. So let's go ahead and define a password. Right now we will define it within the main application itself. We could also define it within any other configuration, but for now let's define it within the main application. So we say at bean name equal to password encoder. We are qualifying this bean with a name because sometimes you may need multiple encoders depending on you may need a separate encoder for tokens and all that. Right now we don't have to worry about it, but I am just giving it a name for that reason. We define a password encoder, and then we return password encoder factories dot create delegating password encoder. So this will become our password encoder. Now we can go back to our actually, come to think of it, the only thing that password manager needs to do is matching of password. So we can for now not worry about it. We'll delete this class and we go back to our original thing that we were doing. Now here we can auto wire the password encoder because we have defined it as a bean. So auto wired qualifier name equal to password. This is useful if you are going to, if you have multiple beans of the same type and you want to choose one by the name, this is the way to do it. In our case it's not required, but we are still doing it. So this is our password encoder. Now we can just check. Now if you see the password that has come in through so we make sure we get both of them. So we say principal dot get password dot is present. If any of them is absent, we should just say bad authentication. So we got it. Now we check the password that is stored in the database is encrypted, and the password that is coming in will not be encrypted. So we have to match it, and the way it really works is that the password encoder class will match raw password against encoded password. So it has a method called matches. The first argument is raw password, that is incoming. So we say password, and the second argument is the encoded password, which is going to be in database. So we say OUE dot, not OUE, OUE. Oh, we already have user entity, so we can say UE dot get password. This is the encrypted password, and this method will match them. If the encoded password matches the raw text password, it means we are successful. Now if this happens, it means our authentication was successful, and now we need to indicate the security system of Spring that the authentication was successful. Now how do we do it? The best way to do it is basically Spring defines something called a user password authentication principle. We need to return that. So we say return new user password authentication token, and this takes as argument, if you look at its constructors, it takes two objects or two objects in a collection. So we are going to use the second variant because we want to provide some authorities. So the first argument is principal, second argument we are going to keep null, and the third argument is user authority dot get authorities from roles. Actually we can just because the mask is contained within user, we can just say get authorities from roles using the mask variant and UE dot get mask. So basically what it is going to do is it is going to create a user password authentication token which will contain the principal that came in, and it will provide it all the authorities that we have defined within the database, and this is how we will control which user has access to what. If the user within database contains that role, that user will get that role, otherwise that user will not get that role. And now along with this we also need to take care of some housekeeping things. Number one, we don't expect a user to send us password all the time. The idea is once the authentication is successful, we will basically generate a token and the user can send a token. So let us define a private method that will generate a random token, private string generate token, and to start with the token could be just bunch of random UUID strings. So we return UUID.random UUID.toString plus dash plus UUID dot random UUID dot toString. So basically we generate two random UUIDs and we concatenate them, and that is our token. I know this is not a great way to generate the token, but I think we will get more complicated as we go along. So now once we have the method to generate this token, we have to set it into the user entity. So we say ue.set auth token generate token. So whatever token we have generated will be pushed into the entity that we have. Then we also need to set certain expiry, and to set certain expiry we can define what expiry we want. Again, all these things get very complicated, but right now that's not the point. The point is to get the basic authentication working. So we can take calendar.setTime, which we basically set the current time, and then we can say calendar.add, and basically let us say to start with we are going to have a 24-hour expiry. So we add 24 hours to it, and that essentially becomes our expiry. So we set the expiry into our user, so basically this is how we have set our database. Now because this is changing bunch of fields in a transaction, we will also mark it with transactional, because that will make sure a Hibernate transaction is created for it. So this is our successful path when the authentication was successful. If the authentication was not successful, what we can do is we can throw one of the exceptions that will throw the error code which will say unauthorized, and Spring already has one such exception which is called bad credentials exceptions, and we can just set a message to it where we can say something like username %s authentication failure. We don't want to give too much detail about what was the failure about. We definitely never want to say that password mismatch, because that gives us an idea to any hacker that the username was successful. So basically we can so basically we have to have two different ways. One is this, another will be here. So if the username was not even found in the request, then we have to send something else, but if the username was found in the request, then we can send this one, and rather than return it has to be throw because it's an exception. Similarly this also has to be throw, and here we can just say that authentication request was invalid because it didn't contain either username or password was not present, and because it doesn't have any variable, we can just get rid of this string.format. We can just return this message. Okay, there is a quote missing. So this is our authentication done. Basically what we have done is, if the username came in, we will authenticate and we will generate a token and return it. Now this will instruct the security provided by Spring to make sure that the right security context is established, so that we are able to put access control later. Now this supports method essentially is used to say which provider should be called, and here what we are saying is, wherever username password authentication is needed, the provider that is needed to be called is this particular one. So that takes care of our provider. Now let's go to the next level. Right now we are not going to worry about tokens. We will do it in, because this way otherwise the video will become very long. So right now we skip the token part of it and some other housekeeping bit. Now the main thing what we need to do, we need to essentially define a authentication filter. Before we do that, so that I don't forget, we have to make some modifications in our user endpoint. Why? Because we need to now encrypt the password. That will happen. Now one thing is, in our get user endpoint, we don't really want to return the password. So we will take care of that later. I think for now let it be. One is the create user thing. In case of create user, what we really want to do is, we want to encrypt the password. We are already getting a user entity, and what we need to do is, so we take user entity dot set password. First we auto wire the, let's auto wire the password encoder, and we set the password after encoding it. So we take the same password, encode it and set it back. And then after that we save it. So that is one change we did. Delete is fine. In case of patch, if we are changing the password, so here again we had the equals check. That equals check should be replaced by the matches thing, and what we are saying is, if the updated object get password which is coming in matches the stored object, which is the encrypted one. If it does not match, it means they kind of represent different things. So we set the password, but before setting it we encode it. So we took care of that. Now let's go to the main bit. How do we take care of this whole security thing so that we don't have to worry about it in each and every endpoint? And the best way to do it is to define an authentication filter. So let's create a class called authentication filter, and Let me just make it a little bigger. Now this authentication has to extend generic filter bean. A generic filter bean always has to implement a method called doFilter, and this is the method that gets called. Basically, if you see, a authentication filter is nothing but a chain of filters. It's a filter within a chain of filter, and this gets called before the request is handed off to the endpoints. Now we need a authentication manager within this, so let's just inject one. Because this class will be created as part of a different security config. There we will provide the real authentication filter, not the authentication filter, authentication manager. For now we just provide one here and initialize it in a constructor. So this is our initialization done. Now let's look at what will doFilter do. So very first thing is we are going to pull out the HTTP request, HTTP servlet request. Let's call it HTTP request equal to servlet request So this is just nothing but casting, so we can just cast it. And we can also pull out the response object just in case we need it. So let's make a response object, HTTP response, HTTP serverless response, servlet response. Now that we have these two objects, let's decide how the authentication is going to happen. So now let's assume that if let's assume that we are going to have an endpoint called /authenticate, which user will call and provide us with a username and password, and you can choose this. I mean, this is up to you. I am just using it because those are the type of things that are generally used. So let's say if HTTP request that get request URI, this is basically the URL that we get, dot toString dot equals, so this is basically, if we are going to the authenticate URI, we need to assume that there are certain, so basically normally what we do is we could just send the username and password as part of a JSON. Now the problem with that approach is that you have to read that packet here and you have to terminate the processing to a further REST call. The better approach that I follow is that if you want to authenticate, you have to send two HTTP headers, one related to username, another related to password, and the same username and password also needs to be sent as part of JSON packet. So first authentication happens here, and then in the endpoint I am going to check and make sure they match, and if they match then only a successful response is returned. So basically let's assume there are two headers available. For the sake of simplicity, let's define private final string, let's call it username header. Let's say it looks like x dash username, and let's say we have a password header, and let's say this calls x password. So now we pull out both the headers. How do we do that? Optional string username equal to, now the header is available within the request. So basically we can do optional dot off http request dot get header, and we pass the username header, and then we say optional string password equal to optional of request dot get header password header. So now we got both username and password, and once we have them we can create our username and password principal, which we had defined earlier. So we say username password principal what was the name of the class? I think I missed the name of the class. Let's see what was the name of the class. User password principal. Let's rename it to refactor, rename username password principal. So now we come back here and we create an object which is nothing but the principal equal to new username password principal, and this object takes two arguments, one is username, other is password, which we already have. So we pass them along, and once we have this, then we basically just ask Spring to authenticate, and the process to ask that authentication is we create an authentication object and that authentication object first let's create a token. So we say username password this is the class that we had used earlier, if you remember, and this is the authentication request that we want to send. And this object has a principal and a password. So we pass it to the principal, username, this is the principal that we have, and we also pass the password to it. So now that we have done that, we just call this function called authenticate, and this function will return an authentication object which will be the response authentication. So, we can say authentication response authentication equal to so basically the request authentication that we have, we use the authentication manager and we call authenticate and pass the request token to it. So, now once we have triggered this, we look at the once this whole authentication happens, and this is where the provider will get called, which we had just defined. Now, we look at the response that we got. So, let us look at the response authentication. This should not be null. If it is null, we clearly have a problem. And response authentication has a is authenticated method. So, it should not be null and is authenticated should be set. If both of these have happened, it means the authentication is successful and we can return response authentication from this method. Oh no, we don't, okay, we have the response authentication and we don't have to return it, we need to set it in the security context of the service. So, we have security context holder. So, we pull out the security context holder dot get context dot set authentication, and we set the response authentication there, and that should be our processing should be complete with that. But if none of this had happened, if there was an error, then we can just throw an exception, which is there is something called internal authentication service exception that we can throw, and we can just say unable to authenticate user. So, now this is basically the simple thing, and once we have done this, then what we need to do is and this will get more complicated. Right now we are doing one type of authentication, and that is just about what we are doing. We can just chain it, and we can say filter chain dot do filter, and we pass on whatever request that we had got, which is the servlet request comma servlet response. So, this will call any other filter that was defined in this queue, and it will take care of it. So, basically if you look at this piece of code is still not much useful, because the only thing that it is trying to do is authenticate a user when he gives a username and password, and you won't be able to do much with that. But because it is a longer topic, we will continue rest of the stuff in the second video. For now, let us make it working. To make it working, what we need to do is provide a security configuration which we can use to tell the system how should we what should be used to apply security. So we define something called a security configuration class, and within that security configuration class, the first thing that we need to define, first thing we need to provide some annotation. First thing, it is a Spring configuration, so we provide a configuration. Then we say we want to enable web security. Then we also want to enable scheduling. This is not immediately required, but it will be useful later. Then we also want to enable global method security, and within that we also want to enable pre-post. So now once this is done, we need to override certain methods. The first one is this class has to extend web security configurer adapter. Now we override the method. The first method that we need to override is the configure method, which takes a auth as a authentication manager builder as a argument, which is this one. So in this, what we really want to do is we want to make it aware of the new authentication provider that we have defined. So we can say, right now we have only defined one, so we can say username or password authentication provider. We have to define a method for it because it's not there. So let's first define a bean for it. Bean authentication provider, username, password, authentication provider, return new username, password. We called it username password provider, so there is no authentication provider there. So here basically we are telling it that we want to use a username password provider for this. So we set that here. Now in the configure we go and add this thing. For now I think this is good enough. The next thing that we really want to do is configure web security. We will do that later. I don't think that is immediately required. So second thing that we need to do is the HTTP security. So we need to use the configure that has HTTP security with it, and we want to first disable the CSRF. Then we want to do we add session management, session creation policy. We want stateless sessions. Then we say and authorize requests and matchers. So let's not worry about actuator endpoints for now. We will just say any request that comes in has to be authenticated, and we want to disable any anonymous request. And the exception handling, authentication entry point, unauthorized entry point. So now we need to define an unauthorized entry point. That is basically another bean that we define here. Public authentication entry point, unauthorized entry point, and we basically return request response auth exception response dot send error, and within that error we send the unauthorized. So we can say HTTP servlet response SC unauthorized. So this is our unauthorized entry point. I think for now. Oh, okay. We also, the filter that we were defining, we need to get rid of this super thing, put a semicolon here, and then we add this filter, add the authentication filter that we have defined, new authentication filter. So we say add filter before, because we want to add it before the basic authentication filter gets called. Basic authentication filter is a class that is already provided. So we want our filter to be called before that, because, and as you remember, our authentication filter needed an authentication manager, so we passed to that. So now we have hooked up our authentication filter in the security config, and now the only thing that is left to do is to define an endpoint for that /authenticate that we had done. So let's define a new endpoint. We go to our endpoint class. Oh, there is still some error in security configuration. So there is a bracket missing here. Yeah. So now we go to endpoints, we define an authentication endpoint, and as we know, it has to be a REST controller, and request mapping has to be at /authenticate. Now for now we can just define a very simple endpoint that basically returns a login response, and we will define this object login response. Method is called login, and it will get a request body. This is the request object that I talked about, that we will send username and password in the header as well as in the JSON, and this is the JSON bit of it, and we will define that as well. So this is our login request object. Now before we continue this, let's define these two POJOs. So we have one login request POJO. Now this POJO is nothing but it needs to contain username and password, and it needs to contain username and password both. So this is what it is here. We need to define getters and setters, because otherwise the JSON won't be generated. So we got this, and we also need to define a response. So let's go to that. Now in a response, what we need is maybe the username, because the user needs to know what user he sent. He would know anyway, but let's add it. Private string username. We also need to send the auth token, and we need to send the expiry. I think these two things are enough. These three things are enough. And let's generate our all getters and setters. Let's go to this here. So now if we have reached this method, so let's first define the request mapping. And this method need not have it needs to have a method which is post, and it should produce a JSON. Let's it's taking the wrong media type. It's going and getting it from the one we want is the Springframework one. Application JSON value. So now we need to inject the authentication within our request. To do that, you can either use security context holder, or you can just say authentication, and this will inject it. Now once we have authentication within our request, we need to get the principal out of it. So our principal is user password principal, username password principal. This is what we have defined. Principal equal to username password principal dot class dot cost authentication dot get principal. Now this is essentially the principal that we have got, and from this principal, the only thing that we have to make sure that the security context that is installed has the same user as what is coming in the login request. So if login request dot get username dot equals principal dot get name, if this is the case, it means we have a successfully authenticated username. We can just return the response object. So we can say return login response. Now the login response object on its own, we didn't define a constructor, so let's define a constructor. Generate constructor. This is the default constructor. Then we define a constructor that takes all the values. We go to authentication endpoint, and if you look at the constructor, username, auth token, and date expiry. So we go to Username is whatever came in login request. Auth token is, we can get it from the repository, because if this authentication is successful, the auth token would be part of the table. So we can auto wire the this thing and find by username, principal.getName, and if OUE.isPresent, get auth token, comma UE.get expiry. So this is our response which we can return from here. Get auth token, and we have to do a new here. Login response, I think one bracket is extra, and it should logically, if everything is working fine, it should not go there at all. But if it goes there, then we can just throw bad credentials exception, and we put a specific error message so that we know that it came through here. So we can say authentication endpoint fatal error for user %s. Comma principal.getName, and we have to add a new here. So that's it. I think this is this class is done, and that is basically end of it. So let's try to run it and see whether it works. Before doing that, we will have to clean up the table, because we don't want the values, because now everything has to be encrypted. So let's drop table user and drop table hibernate sequence, and now we go and rerun it. Okay, it started. Let's go to Postman, and we want to create a new user. So let's go to post, and we send this request, and it is telling us unauthorized. So yeah, this is a problem now we have, because every endpoint now requires authentication, and at this point in time we cannot even create a user. So to solve this problem, in the security configuration we can define URL that need to be escaped, so that we can call them. So let's do that. Temporarily we will, again there is a better way of doing it, but temporarily what we will do is we will go to our security configuration, and we will override another method, which is the configure of web security. So basically this one, and let's make it a little bigger so that it is visible better. And here what we will do is we will just add this web.ignoring.entmatchers, and within that we can say /user. So what we are telling to the Spring that for this particular endpoint, please do not run Spring Security. So now let's run it. Now let's send again. So this is what we got. This is the unauthorized at a it's basically saying raw pass. See, if you see the error here, raw password cannot be null. So that is the issue here. Our request that we had created does not contain password. So let's add a password. Again, we need to fix these errors, which we will do eventually. So let's say user to password, and then we send it again. So now if you see, this is our response that came in, and if you see, this is the encrypted password. So now our table contains encrypted password. Now what we want to do is authenticate. So we keep the request as post, we change it to authenticate, username is user2 and password is whatever it is, and let's try to send the request. It gives us an unauthorized error because there is a null pointer. Oh, so if you remember, we had two headers defined, which we have not added here. So we have to, first thing is, I think we will fix is that there is a space in the username. So let's create another user which does not have a space, which will be easier to handle, because if you have a space in the username while sending header, we have to do URL encoding of it, which is an unnecessary issue. So let's create another user which is where there is no space, and let's call it user1, user1 full name, user1 password, example.com, user1 password, we send it. So this is our user got created. Now we get to authenticate endpoint, and we have to define those headers which we talked about. So the first header was X username and its value is user1, and second header is X password and its value is whatever is defined here, which is this with its 1 in it. So let's make it user1 password, and now we go to body. Here also we make user1 and user1 password. Now let's try to authenticate. We still get an unauthorized which says unable to authenticate user, and if you look at it, if we go to our server, I think we will see this log and it will be easier to figure it out. So let's go to server, and this is the log that we are getting, and basically the error is coming in do filter, where it is saying internal authentication exception, here unable to authenticate user. So this is, if you remember, this is the exception that that we had called in do filter ourselves, and this happens here. Now if you see, the reason is clear why it is happening. It is happening because right here, after we set the security context, we will drop through and we will throw an exception all the time. Basically we should throw an exception only in the case of only in the case when this condition is false. So we have to put this throw into a else clause, so that even for successful authentication we don't throw an exception. So with this being fixed, let's run it again. Hopefully it should work now. So we run it again, and now if you see, we got the auth token back. So the user is now successfully authenticated. It has a security context in, and right now it will not have any roles, because while creating a user we are not setting any roles mask. So all that we will cover in the next video. This video is too long already, so for now I am going to stop this video. This is the, you can say, part 1 of how to implement security. What we have done is we have created a user, we have encrypted the password, we have established a security context, and we are able to handle the authentication endpoint. If you have liked this video, please subscribe, hit the bell icon so that you are notified when I upload the new video. Send it to your friends if they are interested in this kind of content, and thank you for watching this video. Very soon I am going to put out the next video, which will be the part 2 of this, which will take it further to a more wholesome security context for Spring applications. So with that, thanks for watching, and see you later.